All right, Caleb has his paper turned back over and his pencil down, so I know he's ready. He's done. So once you have everything copied, the general plan of action copied, let's go ahead and turn your paper back over and go ahead and put your pencil down and give me a couple of cues that you are ready to start our example problem. Okay. Yes. Yes. There's still a few people with gum in here. Let's remember, starting tomorrow, if you had a chaotic and you're already, I'm not going to make you spit gum out today. But starting tomorrow, I need you to remember to spit your gum out at the beginning of class. Okay, if you weren't here the first day, I had a big to-do about how nice and clean my desks are, because they're new, but still found gum under one, and they haven't even had a year yet. So we're not going to chew gum in here, it's a school rule, and I am going to enforce it to my desks aren't gross, but try to keep them nice. All right, looks like everybody is ready to move on. All right, so this is a general plan of action. It means we won't, sometimes we won't do this exactly this way, but in general, this is how it's going to work. So example number 1, 5 times 5 minus x equals 2 times 3 times x plus 1. So we've got numbers on the outside of these parentheses. There's a couple ways to get rid of parentheses in equations. I'm going to encourage you, if it's not a fraction being distributed, just to go ahead and distribute first. So that's going to be our plan of action. I'm going to go ahead and distribute whatever is on the outside of that parentheses to everything that's in. Remember, parentheses mean multiplication. So that's 5 times 5, or 25, minus 5 times x, or 5x, equals 2 times 3x, or 6x, plus 2 times 1, which is 2. So we've distributed. Now we look through our plan of action. That plan of action, the first thing we did was get rid of our parentheses. The next thing our plan of action says, are there any things that we can combine on the left or right side of the equal sign? So nothing here, because this is a constant and this is a variable term, they can't be combined. Same thing over here. The next thing our general plan of action says, to look for variables on both sides. If there are variables on both sides, we need to get them on the same side. My strategy for you guys, I suggested, was to find the smallest coefficient on the variable term, so that's going to be negative 5, and do the opposite of that. So that's minus 5x. So we're going to add 5x to both sides. So that's going to give me 0 for that variable term. 25 equals 11 times x plus 2. Now we're down to our last step, which is solve. We solve by undoing the operation. So we read it out loud in our mind. 25 equals 11 times x plus 2. So now I know I need to undo multiplication and I need to undo addition. We almost always undo the addition or subtraction first, and that's what we're going to do here. So we're going to get this to 0. If it's a positive 2, we subtract 2. Whatever we do to one side of the equation, we have to do to the other side. So that's going to be 0. 25 minus 2 is 23. 11x plus 0 is 11 times x. Undo that multiplying by dividing. And remember, we're going to give our answer in terms of the variables. So we want our variable on the left side, and that's 23/11. No need to turn that into a mixed number. If you do, there is a way to do that on your calculator. But unless it's a real-world problem, we're just going to leave it as a mixed number. If it's a real-world problem, chances are we're just going to go ahead and turn it into a decimal, because that's how we speak in terms of decimals versus weird fractions. We might say a quarter of something or 25%, but we're not going to say 1/11th of something, right? So, any questions on the first example? Okay. So the next example, we're going to veer from our general plan of action a little bit. So this says 1/4 times a minus a equals a. So the first thing our plan of action says, we're going to get rid of the parentheses. But actually, if there's a fraction that needs to be distributed, we're not. We're going to get rid of the fraction first. And we're going to kind of use the strategy we learned yesterday for getting rid of fractions in general. So So if I want to get rid of this 1/4, I'm just going to multiply this equation by that denominator. So that denominator is 4. So I multiply by 4. Now here's the difference from yesterday, because this 1/4, even when I multiply this 4 right here, eventually this number will be distributed into here. So when I'm getting rid of this fraction, I'm only multiplying what's on the outside of this side of the parentheses. So I'm multiplying about 4 times 1/4 and 4 times a. So that's going to give me 4 over 4, so on the outside of those parentheses, 8 minus a equals a. 4 divided by 4 is 1. I'm going to be okay with you skipping this step and this step, but I just wanted to illustrate for the first day, equals 8. So obviously 1 times something is just that something, right? 1 times a million is a million. 1 times a is a. 1 times 8 minus a is just 8 minus a. And I would be happy, comfortable with you going straight from here to here, but I should see it at a minimum this step and this step. Any questions so far? So if this were a 2, at this point we would distribute.
Why is 4 not a 5?
It is. So Jesse has caught my mistake. Good job, Jesse.
Yeah.
I forgot to multiply the 4. I drew my arrow and forgot it. Good job. So that's not in the parentheses, so that does have to be multiplied by that factor that we're multiplying to get rid of our fraction. Good job. All right, so now I'm looking. I don't have any parentheses now. That was a weird way to get rid of them just because it's 1. We didn't actually have to multiply anything really. So now we're down to nothing we can combine on the left or right side, but we do have variables on both sides. Caleb, what am I going to do using the variables on the same side?
Add the a to the other side.
Beautiful. Negative a, so we're going to add a positive a to both sides. And so that's 8, and that's 8 minus 0, which is still just 8. 4a plus a is 5a. 8 equals 5 times a. We undo the multiplying by dividing. 5 divided by 5 is 1. 1a is just a. When we're going to write our variable on our left side, we want our answer in terms of the variable, not the other way around. Any questions? All right, let's move on to example 3. Example 3, I don't think you have the entire example, so go ahead and write minus x minus 17 on your example. Go ahead and write minus x minus 17 on your example. Every once in a while, you can see it digitally, but it doesn't print when I print those notes, and I think this is one of those occasions. So if did not add minus x minus 17 here, go ahead and do that. So our first step in our general plan of action is for us to get rid of the parentheses. Seeing that what's on the outside of the parentheses is not a fraction, we do want to just go ahead and distribute. So it's going to be 3 times x minus 3 times 5 plus 2. Keep in mind, I'm going to point out the obvious things, or some of the things that are obvious to some of you. That 2 will not get distributed, will not get that 3. So it's going to be 3 times x minus 3 times 5, but not 3 times 2. So 3 times x minus 15 plus 2. The only way that 3 gets distributed to a number is if it's inside the parentheses, and there's nothing in between that number and the parentheses. So here, 4 times x plus 4 times 3, 4x plus 12 minus x minus 17. So our general plan of action said get rid of the parentheses. We've done that. The next thing our general plan of action that says is to combine anything that we can on the left or right side. I'm going kind of fast because with this fire alarm, I'm afraid we're going to run out of time, so I'm going to kind of do some of this for you because we have been practicing this a lot already. This is our 3rd day where we're combining like terms. So on the left side, the constants are your only like terms. So the 3 times x comes down. negative 15 plus 2 is negative 13 or minus 13. On the right side, I'd mark them. If you've got multiple like terms, mark them with different notation of some sort. Now I know I need to do 4x minus x. That's 3x. And 12 minus 17, that's minus 5. So now I have nothing left to combine. Now I'm checking if I'm going by my general plan of action. Are there variables on both sides? Yes, there are. 3x and 3x. So we're typically looking for the smallest coefficient. If they're the same, you just subtract whatever they are from both sides. And this is where, remember, we're going to do one of our special solutions. If the variables disappear, and you can see that the variables are disappearing, 0 minus 13 is negative 13, equals 0 minus 5, which is negative 5. If our variables disappear, and we're going to read that statement aloud, negative 13 equals negative 5. Well, that's not a true statement. That's, in fact, a false statement based on not equal expressions. So some of you on your homework just left your answer like that, right? Remember when we took notes at First Standard, I reminded you, this is not the solution to this problem. This, you should know that once you get to this step, now you have to tell me, oh, the variables disappeared, and it's a false statement, so now I know that there is, in fact, no solution to this equation. There's no value that I could plug in these x spots that would make the left side equal to the right side. And remember, you could also use this null set symbol. Several of you on your homework left it as negative 13 equals negative 5. Remember, that is not the answer. That's the work. This is your answer. Make sense? That it would be the same thing for all real numbers. Make sure you guys are showing work for your problems. Remember, that is one of the things that I have in a frame up on the front of the room. One of the few things that I talked about the first day of school. No work, no credit. If I'm writing it on the notes, you need to be writing on the notes. And if I'm showing the step in the notes, typically I'm going to tell you what you don't have to write. Right? I've done that a couple times. But if I don't tell you you don't have to write it, that's the step you should be showing me. Any questions on that? Okay. And last but not least, so this one is going to veer a little bit from our general plan of action. We have parentheses. That's the very first thing we say to do is get rid of our parentheses in our general plan of action. But this is an exception to that plan. Because if we have a fraction on the outside, we want to get rid of that fraction first. Nobody wants to work with fractions. Could we distribute it first and then get rid of it? We can. It's a little bit more work, but you could do it that way as well. So what we're going to do is we're going to use brackets here. We usually use brackets if there's parentheses already in an equation. Now we're going to figure out what are we going to multiply this whole thing by to get rid of the fractions. So remember, we're looking for a least common denominator. Very good. What do you think it's going to be? It is going to be 12. So for those of you that are like, I don't know, you're looking at the denominators, right? So what number will both 3 and 4 go into? And that number is 12. So we're going to multiply this equation by 12. But remember, just like our other example, if this fraction is on the outside of the parentheses, I'm going to multiply the 12 by the fraction, but not by this. Because eventually, this is going to be multiplied by that new factor. And then I'm going to multiply 12 by this fraction, not by what's in the parentheses, because eventually that's going to get multiplied. So 12 times 1, I'm going to go ahead and show you the long way. This is the way you can kind of shorten, if you like. You could just write 4 there, but I want to make sure I'm being clear. 12 over 4, all times 2 times x minus 3. So if you like, you have to show this step, and you have to show this step, but you can skip the one right above that if you feel comfortable. There's no shame in showing more steps, though. How do you catch careless mistakes? All right, now we're at our first step really on our plan of action. Get rid of the parentheses, and we're just going to do that by distributing. I'm multiplying that number, that factor on the outside, by everything on the inside. And make our way through our general plan of action from there. So 4 times x plus 16 equals 6 times x minus 9. Okay. Mine does that sometimes too. Alright, so now, do I have, as my plan of action says, do I have anything over here or over here I can combine, and I do not? Variable and a constant can't be combined. So now I look, I have variables on both sides. How am I going to get those variables on the same side? Hayden, can you remind me how to do that? So technically, Hayden, we could add 9, but that is not our best way of work. Really what we want to do is we want to work with the variable terms first, okay, so we can get the variables together. So we look at our variable terms. Which one is the smaller coefficient, Hayden, 4x or 6x? 4. Right. So we're going to go ahead and subtract that 4x, and we're going to do the smallest one because we don't have to worry about a negative coefficient on our variable term. So now that's 0. 0 plus 16 is 16. So now I don't have a variable over here. 6x's minus 4x's is 2x's minus 9. Remember 2x's? 2 times x. So 16 equals 2 times x minus 9. So I need to get, now I'm starting to solve my equation. I need to undo an operations. Bailey, what would I do first here? Good. I'm going to add 9 to both sides. So 25 equals 2 times x, that's 0. So just 2 times x. The only thing I have left to undo is the multiplication. We undo multiplication by dividing. That gives me a coefficient of 1x, which we just write as x. And since it's not a word problem, we're just going to leave it in this form. It can just stay in improper fraction. It should be a simplified improper fraction, and this one is. And then it should be a factor that you could take out of both top and bottom. If this were a word problem, we'd go ahead and divide that and say 12.5, or we follow the directions. If it tells us to give it a particular form, then that's what we do. But unless it tells us, that's what we're going to leave it at. Any questions? Shakindra, that make sense? Louise, that make sense? All right. Elena, does that make sense? Okay. Well, that is our last example. If you like, well, we made pretty good time considering we had a fire drill. You can get your phone out and scan and submit your notes. One less thing to worry about. Those are 3 points. If you know you wrote everything down that I wrote down, right now get your phone out and scan and submit. And we're not going to pack up until 19 or 18 anyway, so we got about 1 or 2 minutes. You got 1 minute, but that way I can help you if you don't know how to scan. So go to your to-do list on Canvas. I think that's the easiest way to do it. Go to your to-do list on Canvas. Then hit the assignment 0-3 notes. Then hit start assignment. There'll be a scanner in the bottom right-hand corner. Use your scanner. It may say allow access to your camera. It'll only ask you that once. And then scan front and back. Don't forget your back side. Don't forget your back side. And then you'll hit done. And then submit, I think, and then submit at the top right-hand corner too. So you think you've submitted, but you have to look at the top right-hand corner. After you think you've submitted, there's one other button to press. Go ahead and, if you don't know how to find your comments on Canvas, you can go to the submission and rubric on any assignment. I think that's where you'll find your comments. If you go to desktop, I think you can go in your grades and find your comments there. Okay, so if you did not get a 100 on something you turned in, you can find the comments on there. Hand me your calculator on the way out. Please do not take my calculator with you. All right, if you've already put it up, we're putting it in order by the orange numbers, not the white ones. The orange ones, not the white ones. Thank you so much. I would like for you to get a calculator at the beginning of each class, especially tomorrow. I want to make sure you know how to add and subtract fractions on the calculator. All right, bye guys. Thank you. Thank you. Thank you. No calculator, no calculator, no calculator. Thank you so much.
Oh, I haven't got my username and all that yet because this morning I was late, so I didn't go to the library or whatever.
Okay.
So whenever I get it, then I'll put my assignment.
Okay, so if you haven't done it tomorrow when you get to my class, Elena, I'll let you go down and do it. Remind me. Okay?
Thank you.
You're welcome.